Hello everyone, this is the second part of lecture 7 about the normal distribution. Let's start learning the characteristic of normal distribution. First, normal distribution bell-shaped, symmetrical, mean, median and mode are equal for this distribution. Location determined by mu and the spread determined by standard deviation. The random variable has infinite theoretical range. It means that the values of x for this distribution can be any real number from negative infinity to the positive infinity. This is the graph of normal distribution. As you see in the graph, mu represents the center of the distribution and sigma represents the variation. Here, mean, median, and mode for this distribution always are equal. And remember that it's bell-shaped, symmetrical, because we will use these properties to calculate the probability about this distribution. Normal distribution is one most used distribution. Many variables in real life follow this distribution. In this picture, you can see several normal distribution which have different shape, but all of them has the same characteristic as they are symmetrical, bell-shaped. And changing mu and sigma, we can obtain many different normal distribution. The shape of normal distribution, remember that, only depends on the values of mu and sigma. We can change the shape of normal distribution. Changing mu shift the distribution to left or right. It means that if you increase mu, the distribution, normal distribution, shift to the right. If you decrease it, it's automatically shift to the left. Changing mu, increasing or decreasing mu, change the spread of distribution. So again, I want to mention it that normal distribution only depend on mean and variance. So if you want to show that the variable x normally distributed, you may use this representation: x normally distributed with mean mu and the variance, or you may write here standard deviation also, as a variance sigma squared. Density function of normal distribution. Here pi represent the mathematical constant which approximate value 3.14. E also mathematical constant, approximate value is 2.72. Mu represent the population mean, sigma represent population standard deviation, and x any value of continuous random variable over the range negative infinity, positive infinity. The formula of normal distribution is too complicated. Even it's impossible to calculate the probability using simple methods. So for calculation, we will not use this formula. We will use table, but it's better to understand where this table came from density function. As you see here, we have a coefficient here in the front, 1 over square root 2 pi sigma. Sigma we have here on the front and in the power of the e. And mu we have just in one place. Cumulative normal distribution. As you know, we told before that for calculating probability about the continuous random variables, we have to use cumulative function. So it's also important for normal distribution. cumulative function, as always, we sign by capital Fx0, which represent probability of a variable x less than or equal to x0, where x0 is a given number. In the graph, what does it mean, Fx0? It's the left side area under the graph from x0. You see x0 here, the probability of x being less than or equal to x0, the left side area here, red colored area. And as you know, in order to calculate this probability, we can use integral from negative infinity to x0, density function of normal distribution dx. Okay, but I told you before that the formula of density function is too complicated. We cannot find it directly using density function. Here you may understand how we use cumulative function to find the probabilities. This area, what is represent? This area represents probability of x less than b, x less than b, and x less than or equal to b. We told you before that they are same thing. That's why this area we can sign as fb, which represents probability of x less than b. This area, left side of a, which is fa, probability of x being less than a, and then it's easy to find out probability of x between these two numbers, between a and b. As you know, this area equal to this area minus this area. So this area we can find as fb minus fa, and we can say that also probability of x being between a and b equal to fb, the left side area from b, minus left side area from a. The probability for a range of values is measured by the area under the curve. So the probability of x being between a and b equal to area under the graph and bounded with a and b lines. Calculated using cumulative function like this. Probability of x being between a and b equal to fb minus fa. To calculate the probabilities about the normal distribution, we will use table. As you know, normal distribution depends on two parameters, mu and sigma, mean, standard deviation. But if we have infinitely many values for mu and infinitely values for sigma, we should then make the infinitely many tables to calculate the probabilities directly using the table. Okay, it's not good idea, because using multiple tables is not useful. So we will do something else. There is a special distribution, special type of normal distribution, which called standardized normal distribution, and you must know that all normal distribution we can transfer to standardized normal distribution. We will talk about it later. Right now, let's talk about what is standard normal distribution. In standard normal distribution, the mean equal to 0 and standard deviation equal to 1. Center 0 and the spread is. We will transform normal distribution to standard normal distribution by using this formula. X is our normally distributed random variable, mu the mean of this random variable, sigma standard deviation of random variable. If from all values of x you subtract their mean and divide by standard deviation, you will find out the new variable, which is standardized normal distribution, where automatically mean is 0, standard deviation is 1. Don't forget that, it's very important, when you transform normal distribution into standardized normal distribution by using this formula, the area doesn't change. Therefore, probability doesn't change. So know that why we can use standardized normal distribution, because when you transfer again normal distribution to standardized normal distribution, the area doesn't change. Okay, let's consider example. If x is distributed normally with mean 100 and standard deviation 50. X is a normal distributed random variable with mean 100 and standard deviation 50. What is the z value for x equal to 200? Z represents the variable of standard variable which is standardized normal distributed. Using the previous formula, we can take 200 instead of x, instead of mu 100, and instead of standard deviation 50. We obtain 2. This means that x equal to 200 is 2 standard deviation above the mean of 100. Comparing x and z units from the previous example, here is the graph of normally distributed random variable x with the mean 100. We have value here 200 and standard deviation of this distribution is 50. When we apply the formula, the mean 100 turns to 0, standard deviation turns to 1, and the value of 200 turns to 2. We obtain the new distribution, which is standardized normal distribution. And note that when we transfer normal distribution into standardized normal distribution, the shape of graph is changing. But don't forget that area doesn't change. Scale, the form is changed, but the area doesn't change. Okay, total area under the graph is 1 as always, and of course the probability, for example here x being between 100 and 200, if it's something, then the probability of z being between 0 and 2 will be the same thing. This is most important property of standardized normal distribution, which we will use for calculate the probabilities. We have a table for standard normal distribution. You can find any cumulative probabilities using this table, and as you know, we can transfer each normal distribution, every normal distribution, to standardized normal distribution, and after the transformation we can easily find out the probability. Here let's consider the simple example. Suppose that we have normally distributed random variable with mean mu and standard deviation sigma. The question said that what is probability of x being between a and b. In order to find out this probability, we need to transfer this normal distribution to standardized normal distribution. Therefore, we will change all points of this distribution of x to standardized normal distribution using the formula. If you turn x to standard normal distribution, you need to sign it as z. A, if you want to transfer to standardized normal distribution, you should write here A minus mu over sigma, B minus mu over sigma. And because when you do this operation, area doesn't change, as we told before, this probability of x being between A and B equal to probability of z being between these two numbers. And because before we told you that the area between two numbers you may find using cumulative function like this. F this number, because this represents the left side area from B, minus F this number, because this represents left side from A. Of course, this total area minus this total area equal to area between these two numbers. We know that density function is a function which have some properties. One of them is that the area under the curve of density function equal to 1. So this area for a normal distribution is 1. Yes. And also we said that mean represents the center of the distribution and the graph symmetrical relative to mean. So what does it mean? It means that mean divide the graph into two parts. In both sides, area under the graph, because of the graph is symmetrical, equal to 0.5. Because the total area is 1, both of them are equal. Therefore, both of them should be 0.5. That is, probability x more than negative infinity less than mu is 0.5, and probability x more than mu less than positive infinity also 0.5. In standardized normal distribution, we can find out all cumulative functions for z. For the given z value, this table shows fa, that is cumulative value of a, area under the curve from the negative infinity to a. If we have a and fa means probability of z less than a. And what does it mean? It means that this left side area from A. Now let's consider the table. This is the cumulative standardized normal distribution table. Here we have, in this part, we have negative values of z. Here we have positive values of z. Z value started from negative 6 and ends up with negative 0.1 and then 0. Here from 0, positive 0 till 6.0. As you see in this part, in green colored part, we have only first decimal numbers. And the second decimal number we must take from this part. For example, if you consider negative 3.72 z value, you take negative 3.7 from here and 0.02 here and find out intersection. The intersection negative 3.72 represent the probability, this number represent the probability of z less than negative 3.72. Suppose that we want to calculate probability of z less than 1.65. Because it is positive value, we take 1.6 from here, and the second decimal number here, 1.65. And we find out here something like this, 0.9505. If you show this 1.65 here, the probability of x being less than this 1.65, that is this area, equal to 0.9505. More examples. Suppose we want to calculate probability z less than 2.00. It's, we find out from table, 0.9772, which represent the area left side of 2 and under the graph. Let's find out it from the table also. 2.00 we need to find for z value. 2 point positive values here, so we take here 2.0 as a first decimal number, and because we have 2.00, we should take from this column the number, corresponding number, and as you see it's 0.9772. It means that the left side area, if we have 2 here, 2, the left side area from 2, this shaded area, equal to 0.9772. One more example about negative values. Suppose that we want to calculate probability of z less than -2. By using a table, you can easily find out that it's 0.0228. It means that if this is the graph of standardized normal distribution, this is its center, -2 here, the left side area from -2 is 0.0228. If from 1 you subtract this number, of course the total area under the graph is 1, therefore if you subtract from 1 this area, you obtain 0.9772. Let's consider the previous example also. In previous example, we find out that the probability of z less than 2 is 0.9772 from the previous example. And so the right side of it is 0.0228. You see, the right side of 2 is equal to left side of -2. This is interesting thing, and this happens because the graph is symmetrical. So right side of 2 equal to left side of -2. You may use it for some questions in order to quickly solve the question. For example, if you know the right side of 2, you automatically you must know that the left side of -2, same thing. Also, look at the right side of -2, right side, equal to left side of 2. In previous examples, we want to calculate directly probabilities about standardized normal distribution. But for now, we need to consider the case where x is normally distributed. When x is normally distributed, we should follow this following steps. First, in order to find the probability, we must draw the normal curve for the problem in terms of x. Second, translate x values to z values. This is second thing. And the third thing, use cumulative normal table to find the probabilities. Suppose that X is a normal distribution with mean 8 and standard deviation 5. What is probability of X less than 8.6? You should draw the graph of normal distribution. The center of it is 8. 8.6 is something here. We must transform normal distribution, this is our normal distribution, to standardized normal distribution. As you see, here left side X less than 8.6 and here left side of 0.12. Where we find out 0.12 from the formula X minus mu over sigma. X 8.6, mu 8 and sigma 5. We obtain 0.12. Draw this graph. On this graph, write here z, here 0, here 0.12 and the left side. It's interesting that if you do this process of transformation normal to standardized normal distribution, area doesn't change. So this probability equal to this probability. And this one you already know that we can calculate by using standardized normal distribution. Let's now use this table. This is the part of table. Here 0.1 from this first column. From the row, first row, you select here 0.02 and in the intersection of them you have 0.5478. So this is our answer, 0.5478. Don't forget that to calculate this probability, first turn X values to Z values and then write that X less than 8.6 equal to Z less than this. And then it's better to write it as a cumulative function, 0.12, and then directly using the table find out this value right here. 0.12 here, 0.1 and 0.02 here, 0.5478. Sometimes we need to calculate right side area. We call it also upper tail probabilities. Suppose again we have X which is normally distributed with mean 8 and standard deviation 5. What is probability of X more than 8.6? In previous example we consider less than 8.6, but here more than 8.6. Again we will do the same procedure for calculate the probability. First, draw the graph. Find left side area from this from the z value 0.12. This is 0.5478, which we already found in our previous example. And then right side area equal to 1 minus this, 0.4522. So answer is this. You must know that in the table of normal distribution you have only left side area. So to find the right side area you need from 1 subtract left side area. Okay, to calculate the right side area, first you must calculate the left side area, and then from 1 subtract left side area, you obtain right side area. Okay, so look at probability of X more than 8.6 equal to probability Z more than 12. It's equal to 1 minus probability Z less than or equal to 12, and this equal to 1 minus 0.5478. We calculated in our previous example, so answer 4522. Now we will do reversing, we will find out x values using given probability. Here is the steps for this process. First, find the z value for the known probability. Second, convert x units using the formula. This is not new thing. This is the same thing but written in different form, which you already know. You know, the z equal to x minus mu over sigma. Yes, this is the same formula, just written in different form. We will use this to find out the x values. Let's consider example. Suppose x normally distributed with mean 8 and standard deviation 5. Find x values so that only 20% of all values are below this x. What does it mean? We need to find out here x value from which 20% of the values less than. Okay? 20% you may turn to probability by dividing it by 100. 20 divided by 100 is 0.2 or 0.2000. So we need to find out here the x value from which left side area from it equal to 0.2000. Okay. First, for 20% area, if you want to find the z value, we turn 20% to the probability. It's 0.2000. From inside of table, we must find out from inside of the table. This is the part of table. From inside of table, we must find out the probability, which is very, very close to 0.2000. Here, among the numbers, you can easily find out that it's 0.2005. So, the z value corresponding to this area is negative 8.4, negative 84, negative 0.84. Yes? So, we find out z value from which left side area equal to 0.2000. And now it's time to find x value. 0.2000 from inside of table, it's not hard to find out. You see here numbers more than 0.5. So no need for searching it here. You should search 0.2000 here. You see 0.0, 0.0, 0.0, here 0.1, okay. Here 0.2. And you see 0.21, 0.2090, 2061, 2032, 0.2005. Only this number very, very close to 0.2000, and the z value here negative 84, negative 0.84. Now finally x values. We use this formula, x equal to mu plus z sigma. Mu is given in the question 8, sigma 5. Just z we find out, it's negative 0.84. So answer is 3.80. Now the conclusion is that 20% of values from a distribution with mean 8, standard deviation 5 are less than 3.8.